What if you don't want to use a table? Well, it is very possible to send secret messages by using an interesting mathematical function that is related to Caesar's cipher. Let me show you what I mean. This function is known as the modulo function, and I know that you might be familiar with it, but if you are not familiar with it, that is fine. So let us look at a simple example of the modulo function. Let us look at 8 mod 5. Now, 8 mod 5 gives us 3 because the modulo function is only interested in the remainder of the division operation between the two numbers. So essentially what you are doing is 8 divided by 5, which is essentially 1, but you have remainder 3. And it is that remainder 3 that you're going to write down as the answer to the modulo function. So let me give you a little exercise to see if you understand the general idea. Can you pause and try this exercise? 21 mod 4, 12 mod 7, 23 mod 3. And can you just pause on the video? If you paused on the video and you did the calculations, you should get these answers. 24 mod 4, 21 mod 4 should give you 1, 12 mod 7 should give you 5, and 23 mod 3 should give you 2. So I'll just do one of them for you. 21 mod 4, essentially 21 divided by 4, will give us 5 remainder 1. And remember, in the modulo function, you want to ensure that you have only the remainder as the answer. So let us continue. So back to Caesar cipher. When using a Caesar cipher, you assign each letter to an index starting from 0. And in this case, we have a set of alphabets, a set of letters making up 26 in number. So how do we use this to compute Caesar cipher? It's very simple. We use the formula stated below. We take the plain letter index plus the key, and then we do the modulo function of that with the total number of letters. You can see the formula at the bottom of the screen. And let me show you how to use it. So, take for example, now we want to encode the letter A. The total number of letters is 26. The letter index is 0. And the key, that is the number of spaces to shift, is 3. So using the formula we showed you in the previous slide, we know that our letter index of letter A, as you can see on the screen, is 0, and our key, as stated on the slide, is 3. And we are now applying the modulo function to 26. And remember, 26 is the total number of letters. So when we compute it, we have 3 modulo 26. And that gives us 3. Based on that, we know that the letter at index 3 is D. Therefore, we can say that when we want to encode the letter A, we're going to encode it as D. Let me give you another example with the letter T. For the letter T, we know that the total number of letters is still 26. The letter index is 19. And the key is 3 because we are using that same key. which is a number we have chosen. So applying the same formula, we take the letter index, which is 19, and then we add the key, which is 3, and then we apply the modulus function, which is 26, and that gives us 22, because 22 modulus 26 is 22. Why is that so? Because 26 can't go inside 22, so the answer is actually 0 remainder 22, and therefore our modulus is 22. So all we have to do now is to take the index of our computation, which is 22, and check it, and we see that that is the letter W.